Hello everyone, my name is Abhishek and welcome back to my channel. A lot of cloud and DevOps engineers are scared of databases. In fact, a lot of times I keep getting these questions on the channel. Abhishek, should DevOps engineers really understand about databases? What kind of tasks do DevOps engineers perform with respect to databases? Can we skip learning databases? Now, if you're also worried about these things, just try to watch this video till the end. In next 20 minutes, I will make sure you are comfortable with databases. Because the scope of cloud engineers with respect to databases is very, very small. I'll explain you what are the different types of databases. I'll explain you how you use these databases in real time. And I'll also show you different tasks that DevOps and cloud engineers perform in real time with databases. So make sure you watch this video till the end. Let's start with understanding what are the different types of databases. Typically, as a cloud engineer, you will be dealing with four types of databases. Number one is relational databases. Number two is non-relational databases. Number three is in-memory databases. Number four is time series database. Now, what are these databases? Let's go through each one of them and understand real life implication of these databases. First one is relational databases, very popular one, quite widely used. Now, in relational databases, data is stored in terms of tables and organized into rows and columns. We will take one example. So if you're working, let's say, in a banking company, you will most likely be asked to create a relational database by your developers. Why? Imagine your development team wants to deal with employees' data. So they want to understand which employee belongs to which department of the bank. They want to save these records. How would they do this? First, they will create a table. Okay. So this is the first table they will create in the database. So this table has ID of the employee, name of the employee, and age of the employee, for example. ID1, name is Abhi, age is 25. ID2, name is XYZ, age is 30. So this way, in the first table, let's call this as employee ID table. Within this table, these records are saved. In the second table, again, what the developer does within this database, employees database, developer creates another table. Within this table, what developer does? So developer stores department ID and the name of the department. For example, department ID is 101 and the name of the ID for 101 is, let's say, the safe department. 102, credit cards department. 103, debit cards department. This way, developer creates another table. This is for the departments. And finally, developer creates a table which establishes a relation between these two tables. And this table has the output that the organization is looking for. What does this has? What is the ID of the employee and what is the department of the employee? So this table has a mapping EID, employee ID, 1 belongs to department 101. Employee ID 2 belongs to 102. Employee ID 3 again belongs to 101. So this way, this table is created by establishing a relation between employee table and departments table. Because the data across the tables or entities in the table, they have relation. This is called as relational database. And in relational database, as I told you, usually data is stored into the tables and organized into rows and columns. And the data that is stored into the relational database tables is usually consistent in nature. That means this data this data looks consistent. Even when there is a new employee, you know how the data would look like. Typically, employee ID can be an increment of it. Name would be a string of definite characters, and age would be between 0 and 100. So you know how the data would look like because it is consistent in nature when it comes to relational databases. Now, non-relational databases, when you don't have such consistent data, you want to store some documents or you want to store any sort of key value pairs. Now, key value pair can be anything, right? Only consideration, there has to be a key, there has to be a value. And let's say you want to deal with data like documents or key value pairs or even graphs, then you have to create a non-relational database for your organization. But Abhishek, what are the examples of relational database? We learned about the relational database concept. The popular ones are Postgres, MySQL. So these are very popular relational databases. Even Oracle is a very popular relational database. Now, when it comes to non-relational databases, that is, you don't have consistent data, you want to store any sort of key value pairs or documents or graphs, then you go for databases like MongoDB or Cassandra DB, or even the popular choice in this space is DynamoDB. So these are popular non-relational databases. You will ask your developer what sort of database to create. Developer can provide you the requirement and you can decide which kind of database to go with. Or even your development team can tell you, but just for your understanding, I'm explaining you the concept of the databases. Now, in-memory database. Let's try to understand this through an example instead of definition. So these days we all use e-commerce. So when we use e-commerce, when we add a cart to the item, you will realize even when you log in back, you see that item in the cart. Even for some reason, if the e-commerce site goes down, you log in after 1 month, you log in after 1 year even. During this year, the e-commerce application might be down because it's practically impossible for applications to be 100% up. But still, when you log in, you will see the same items in the cart, right? This is because the applications, as soon as you log in, it fetch the state of your application or it fetch your state of your login, right? So how does these things happen? This happens because applications store the information into the read-write operations, right? So here, the popular databases are Redis, Memcached, even Valkey, right? These are very popular options when it comes to in-memory database. As the name suggests, when it comes to in-memory database, these databases store the memory in RAM. The relational databases, non-relational databases, they deal with huge amount of data. So when it comes to these databases, let's say if you take Postgres as an example, you have a different virtual machine which is running the instance of Postgres, but data is stored into a huge storage server or it is stored into a huge volume. It can be SSDs, it can be Google storage bucket, or it can be EBS volumes in AWS, anything. So this is how Postgres stores the data isolated from virtual machine or the compute. But when it comes to in-memory databases such as Redis, they typically store the data onto the RAM of that machine. So if you are creating the virtual machine, in this case, more or less the data and the storage is tightly coupled, if not completely isolated, right? The popular in-memory databases requirement is when the developers are performing session management or when your developers are dealing with caching information or dealing something like the leaderboards, right? These are popular use cases where in-memory database is used. Finally, time series database. Time series database is used when you deal with data that corresponds to timestamps. For example, your organization is working on building a monitoring stack, or your organization wants to use a monitoring stack where data is related to your timestamp. For example, CPU utilization. At 10:00:01, the CPU utilization is 70%. Then at 10:00:02, CPU utilization is 80%. So if you want to store data with respect to the time frame or with respect to the timestamps, and the data is very fastly changing, then you go for a time series database. And the best example of time series database is InfluxDB, right? Or the timescale database, or even if you are a cloud aspirant, you would know Prometheus. Prometheus also has a time series database. So these are the popular time series database, and the use case is monitoring or observability or IoT sensors, anything related to metrics. You deal with these four kinds of databases as cloud engineer. A quick recap, very quick recap. Relational database stores the data into tables, rows, and columns. Relational database is the most popular database that is used. Most likely you'll be working with relational databases, because when it comes to the traditional applications like banking applications, e-commerce applications, storing user details or storing employee details happens through the relational database. Non-relational databases, when you don't have consistent data, when you want to store different types of data, you want to store documents, key value pairs, graphs, then you go for non-relational database. When your application is dealing with session management, caching, leaderboard, even queues, for example, then your organization would request you to create an in-memory database. Finally, time series database, when your organization is dealing with metrics, maybe it is dealing with some monitoring stack, or your organization is dealing with even cases like IoT sensors, then your organization would require a time series database. Now the big question is how to create these databases. Okay, you know, you might have a discussion with your developer, you might have a discussion with your development team, and you have decided you want to go with a relational database, and you want to go with Postgres, a specific version of Postgres, let's say Postgres version 17. Understand that you have come to this agreement. But the big question as DevOps and cloud engineer is how do you install and how do you configure this database? This is one of your major tasks. Now there are three ways of achieving it, right? This is the point that you have to focus more as a cloud engineer. You have three options. One, on-premises. Two, self-hosting. Three, managed hosting or managed service. What are these options? On premises, where you set up your own data center for your organization, or you buy some servers for your organization. Within those servers, you set up a cluster of your database. In this case, you set up a cluster of Postgres and you install and configure with the required version. In this case, let's say V17 of Postgres. This is option one. Option two is self-hosting, just like on-premises, but I'm talking about cloud self-hosting. In this case, instead of buying servers, you would rent the servers from the cloud provider. Again, the concept is more or less the same. On the rented servers, along with the storage, you install Postgres, a defined version, let's say V17. In this case, the advantage over the on-premises environment, of course, I'll talk about individual advantages. But the main difference here is that the virtual machines that you have set up, you don't have to maintain them. Like you don't have to take care of their operating system. Finally, the managed services option, where you just go to a cloud provider, let's say Google Cloud Platform. You go to its managed database offerings like Cloud SQL, and within the Cloud SQL service, you will just look for Postgres. You will just look for the service that you need, and you click on few buttons. That's it. Postgres is installed and configured for you. So these are the three options. Now let's try to understand when should a cloud engineer should go for this, when should a cloud engineer should go for this, and when should a cloud engineer should go for managed services option. When you're dealing in a highly secure environment, maybe you're working for a bank and you're dealing with important bank related data such as the employee details or customer details, client information, the policies that they have taken, right? Maybe anything related to the user sensitive information, you should definitely go for a data center or an on-premises setup, because you cannot trust on the security of your data on the cloud providers uh, security configuration that they have set up. So in this case, strictly you go with on-premises option. But let's say your data, of course, your data is important, but let's say you can trust on the cloud provider on this particular data, then you can go for self-hosted option, where you set up bunch of virtual machines, you create a cluster out of it, and because you are renting it, when you don't need it, you can downscale it. When you need it, you can upscale it. So you can save some money compared to this option. You can save some money, but you have to still take care of patching the version of the database. So today your database might be V17. Tomorrow when you need V18, you have to maintain the database. So the advantage that you get here is costing, but the disadvantage that you still have here is that you have to maintain the databases. You don't have to maintain patching of the operating systems. Now finally you have the managed database offerings, where you have very less work to do. You just have to go to the cloud provider. You just have to click few buttons. You have a complete managed solution for you. The advantage here is that very, very low maintenance. Operating system level patching is done by the cloud servers. Database related patching is also done by the cloud servers. Version upgrade, security patches, everything is taken care by the cloud platform. Of course, there is a disadvantage, that is costing. You will be costed more, but here, because it is efficiently managed by the cloud provider, if you don't efficiently manage this, then this can be cheap as well. What do I mean by that? I don't want to confuse you. I'll try to make it very clear. Here, auto scaling should be taken care by the cloud team. If the cloud team is not doing the auto scaling well, that means they are wasting the resources. But in this case, managed services takes care of upscaling and downscaling. So they make sure whenever you don't need the compute, whenever you don't need the storage, it is rightly sized all the time. So this way, although it is costlier when compared to self-hosting and on-premises is debatable, but it is less costlier when compared to self-hosting. If this is not managed well by the cloud team or any team that is responsible, managed hosting can be of less cost. So overall, it depends on your organization. Whether you want a very, very secure solution, go with on-premises. Do you want to you know uh, do it by yourself instead of going for a managed service? Do you want to rent some servers? Do you want to manually take care of upscaling and downscaling because you have a team that is set up by your company? You are more number of cloud engineers already within the team. Then you can go with this option because you have a large team and you have dedicated people who can take care of upscaling and downscaling. When you have a small team and you don't want to build more cloud engineers who will be taking care of upscaling and downscaling or auto scaling, then you can go for a managed cloud offering and you can rely on the cloud platform about the auto scaling as well as about the security of the data that you are storing, right? So this is about different types of installations that you go for. Now, Abhishek, which is the popular one, right? Out of all of these things, what is currently in place in 2025 that is used by most of the teams? So today, a lot of companies are moving towards managed services because what the cloud platforms do today, they take open source solutions, right? Even it is the case with Kubernetes, it is the case with Redis, Valkey, what cloud platforms do, even Kafka. So cloud platforms take open source offerings, they build managed services of the open source offerings, and they distribute these managed services to the cloud engineers who are using the cloud platform. So this way, managed services costing can also come down a little because they are open source offerings, right? Open source is maintained by someone else. And companies have realized the advantage of managed service. They can manage them using small teams. Typically, in a lot of companies, DevOps and cloud teams are very small. So that's why companies are moving towards managed services. So if you are giving an interview, you can go with this option and you can say you have used managed services in your organization. Now let's try to see. Now that we understood what are the databases, now that we understood what are the different ways of hosting a database, how to install, how to configure, let's see this in practice. So we will get to Google Cloud Platform. I already have a database running, but I'll create a new one. So you can also do it along with me, or you can just give it a try after watching the video. So what we'll do now is we will first start with creating a project. If you want to do it on AWS or Azure, you can go ahead, you can do it. But if you want to do it on Google Cloud Platform, I already have a repository. You can just come to day 10, right? Cloud SQL. You can see what is covered as part of this video. And if you go to the day 10 folder, you will also find a README file which has all the steps related to today's video, the theory part as well as practical that we are doing at this point. Cool. So now step one, if you're using Google Cloud Platform, is to create a project and make sure once you're done with this demo, you get back to this project, disable billing and delete the project because database does not come for free. If you're on free trial, you get it for free, but it's costly. It can eat up your resources that comes with your free account. So after watching the video, after practicing, please go ahead, disable billing and delete the project. Okay, first step is to look for Cloud Shell, my bad, Cloud SQL. Okay, so this is Cloud SQL. I already have a Postgres instance, but I'll create a new one. Very simple. Click on create instance. Cloud SQL is for relational databases. Anyways, if you want to create other databases like in-memory database or time series database, in that case, this Cloud SQL service does not work. You should search for the database that you are looking for. If Google Cloud Platform has an offering, you can do it. Otherwise, you have to go with option 2, that is self-hosting your own services. Because cloud platforms do not offer managed services of everything. They only offer managed services of the popular solutions. For example, if you want to go with Oracle, right now there is no Oracle managed service as part of Cloud SQL. So in that case, you have to go ahead and install Oracle by yourself on the virtual machines that you rent on the cloud platform. Okay, I'll go with Postgres. Cool. So there are two options here. And this is very important to understand. When you're going with managed service, there are usually multiple tiers. So in this case, Enterprise Plus is a tier and Enterprise is the other tier. The major difference between them is SLA. Now this is on every cloud platform. So SLA plays a very critical role if you're working for critical applications. Let's say you are working for an e-commerce application and you cannot afford even 0.01 percentage downtime, then you should go for Enterprise Plus. Maybe you're working for a startup mid-scale company. You can afford 0.05% downtime, which is actually very less. Then you can go for the enterprise plan. You can see the cost here right now with the default options. It is 1.23 US dollars, but I'll show you how you can bring it down. One is for your hobby project or for your development environment, you can go with enterprise plan. Then you can go for a small sized database instance. In this case, I'll go with 2 CPU, 8 GB RAM, and 10 GB storage. Also, for my practice, I don't need high availability. If you need a production environment, you would definitely do that. Now, this can be asked in your interviews as well. What kind of configuration uh, you take care of when you install a database or when you create an instance of your database? Then you can say that on the production environment, we go with high availability. On the lower environments, we choose a single zone database instance. The reason is very simple. When you go for high availability, a cluster is created for you where in the cluster you have one copy of the instance in A zone and other copy of the instance in B zone, so that even if one of the data center goes down in a particular region, you still have your instance up and running. Now the version of Postgres, this is the primary advantage, right? You can choose any version and at any point of time you can easily upgrade between the versions. Instance ID, you can pick up an instance ID. So let's say DemoDB, right? I'll go with this. You also need to pick up a password, and these are the credentials that you'd use to log into the instance once it is created. Maybe to create a database or maybe to create tables within the database. So I'll just say, okay, something very strict because it's a database. Choose region. Now in this case, you should choose a region that is nearest to your client. Not to you, but to your client, because your client requests or makes a request and your client should receive the response fast. So do not choose a region that is nearest to your development team, but always pick the one that is nearest to your clients. Okay, I'll just find one. Great. Single zone one more time. Customization of the instance. Now, these are the configurations that you can talk in the interview. When interviewers ask, what did you do with your database? You can talk about these configurations. I made sure my instance is highly available. I make sure the production instance is upscaled and regular instances are downscaled so that I can also save money for my organization. Right from 1.23 US dollars, it went down to 0.17 US dollars per hour. So if you consider a span of 1 year, you are typically saving 365 times 24, right? Per day, you are saving 24 US dollars multiplied by 365. So that would typically come up to 10,000 US dollars for your organization, just on a single instance, right? So this is where cost optimization comes into picture. You should be very good at it. Cool. So single zone machine configuration, I can even downsize it if I want. On the hobby project, I can even downsize it and bring it to 0.08 US dollars. Data caching, that's totally fine. Storage, there is one important setting here. Enable automatic storage increases. Because in databases, typically database is storing data, and most of the times you cannot predict the amount of data that you are storing. Maybe you are storing, let's say, just for easy reference, let's say you are storing some logs from the application or some documents from the application on your MongoDB. At one point, you might have less data, but when there are concurrent user requests, you might be pushing a lot of data into a database. So if you set up with a fixed size, even it can be 250 GB, at some or the other point, the storage will be done and you will be looking for more storage. You will not have time because users keep accessing the data. So what you can do is you can play safe and you can go for enable automatic storage increase. At any point, if you select 250, at any point, if the storage is 200 or 220, cloud platform automatically adds additional storage. Now, finally, the important setting, although there are a lot of settings, one important one is securing your instance, securing your databases. How do you do that? You can enable private IP. So you can disable public access to your database and you can choose in which VPC you want your database. So if you checkbox this private IP and if you select, let's say, any particular VPC where you want your database, now the scope of your database will be restricted to that VPC. To even secure your database, you can also authorize certain networks. I'll try to explain this further because security is very important. So basically, when you create a Postgres instance or when you create database for your Postgres from the instance, you can place it within a VPC. And what you can do is you can disable public access to it. So this will be in a subnet and you can disable public access so that only people can access within this VPC through the private IP address. If it is public, anybody in the world can access that database, which is a bad practice. You can further secure it because within a VPC, you can have multiple subnets. Let's say you want application within the subnet to access database, application within the subnet to not to access the database. So what you can do, you can authorize if this subnet range is 10.10.0.24 and this subnet range is 10.10.20.0/24, you can only authorize this network so that only applications within the subnet can access the database. Further, you can do a lot of firewall settings, a lot other things, but for now, understand these things. One is private IP and other is authorize particular network. For your hobby project, you can also authorize your personal machine, that is your laptop. So from your laptop, you can access the database instance, but you have to select public IP in that case because your laptop is not in the VPC range. Otherwise, you have to enable VPN. Cool. So these are the options. Okay, I'll uncheck few things because there is contradicting information here. Okay, cool. Cool. So I'll click on create instance and within few minutes, I will have my database up and running. So you can see, not database, my bad. I will have my instance up and running. Now within this instance, I can create databases, right? So I've just created an instance of Postgres. Within that, I can create databases. Within the database, I can create tables. Within the tables, I can import data. We'll wait for the database to be up and then I'll quickly show you how you can perform those operations through the Cloud SQL user interface. Perfect. So we have the instance created. Now, upon the request, you can just head to databases. So you have the default one. You can just create more databases. For example, I can create AppDB, right? And I can give it to a particular team who is requesting for a database. Now within this, I can grant permissions to the users. For example, permissions to the developers, permission to the QA team, and anyone who wants to write to the database. Otherwise, I can also define permissions using IAM groups. So I can define user read access to certain people on the database, anything that you can do with IAM capability, right? You can define user level access, you can define read access, write access, delete access, anything provided by the IAM policies. Going back, so you can also connect to the instances or databases through the using the SQL Studio. If you're not comfortable with the Studio, if you don't want to access it through the UI, you can also use Cloud Shell and you can access using the PostgreSQL client on the Cloud Shell. So it is pre-installed. I will show you that in a while. For now, let's select the database. Okay, for example, Postgres database. User is Postgres and password authenticate. So I am connected to the database. Now I can click on table, create table. I can create tables. I can add couple of tables. I can add data into the tables. Anything that I want to deal with this database. So this is how you add data. This is how you create users, how you create databases. Finally, you can also head to a particular database and you can import the existing data or export the data. Abhishek, why cloud engineers do importing and exporting? Very simple. So as cloud engineers, you might be using, instead of a managed database, you are using self-managed or self-hosting. This is one use case where when you want to upgrade the version of the database from Postgres 16, you want to go to Postgres 17. In that case, you might want to take a copy of the data in case there is a corruption of the database or any issue with the database. You might want to export all the data. And once the installation is done, if something is wrong, you can import the exported data. Or second use case, if not for upgrades, you might be dealing with a production issue where customer has reported issue on production. Okay, you can explain this use case in the interviews as well. Customer has reported issue on production and developer is asking for a similar lower environment so that developer can replicate the environment, replicate the issue, and identify the root cause. So in this case, what you can do is on production database, you can export the data. So you can take the production database data. You can come to the managed service. You can create Postgres v17, create a database instance in it, and you can import the exported data. Right? So you can import the exported data so that you have a similar lower environment as your production environment. So this is why as cloud engineers, you import and export data. It's very simple. Now I'm in the demo DB. I can just click on import. I can import the data from my Google Cloud Storage or even from my laptop or the device from which I'm using this managed service. It's still loading, but you would see those two options. One is from your laptop or other is from the Google Cloud Storage or GCS bucket. So these are the common activities that you would perform as a DevOps engineer or a cloud engineer. Now the activities are same. Cloud platforms might change. You might be using RDS on AWS or you might be using XYZ cloud platform. They might have different managed services, but the operations are same. One, installation and configuration. That is the first activity that you do. Install and configure. Two, managing users, integrating users with IAM. Three, if required, you create database instances, and if required, you create tables, but which is very likely, less likely. Four, apart from install, configure, database, tables, you would also work on import and export of the data. Right? So this is about databases for cloud engineers. One final thing, as I promised, if you don't want to use this interface, you can also go with Cloud Shell. Today, Cloud Shell is available on all the major cloud platforms. So you can use the Cloud Shell environment. And advantage of Cloud Shell is that it comes with PostgreSQL client or MySQL client already installed. So if you just say PSQL, you can see it has the client already installed. So using the PSQL commands, you can connect to your database. You will find that in the GitHub documentation, all the commands related to it. Now, as final step, I'll go ahead. I will disable the billing for it. For that, I will search for the billing service. billing. Okay. I'll go for the managed billing account, manage billing accounts, and click on this option, disable billing. Once the billing is disabled, perfect. Now you'll not be billed any longer. Head to the manage resources, databases for DevOps, delete the project. So this is a project ID, delete. Perfect. So that's it for today's video. I hope you found it interesting. If you have any questions, do let me know in the comment section. See you all in the next one. Take care, everyone. Bye bye.